So we are now on our second to the last topic for this semester for VEM 007, and this is lactation. When you see lactation, this means milk production. And the reason why we are classified as mammals, because we have mammary glands that produce milk, particularly the female of the species. Its primary purpose is to provide nourishment, and the mammary glands are the organs of concern. So we have the different species with the number of glands they have, and the number of teats that they have per gland, and number of teats that they also have, and they also have the number of strict canals in per teat and the position of their glands. Our cows, they have 4 glands, and each gland will have 1 teat each, thus 4, and per teat has 1 strict canal, and the position is inguinal, meaning it's in their singit in our language. So it's in the pelvis, right between the hind legs. The mares, they only have 2 glands, but it's complexes. And the number of teats they only have 2. So 1 per gland. For the strict canals, they have 2 on each teat or nipple. And the position of the glands is inguinal. The ewes, they also have 2 number of glands. They also have a total of 2 teats, so 1 teat per gland. And for strict canals, they also have 1 and 1 per teat, and the position of glands is inguinal. So is the does. So are the does. For the sows, they can have 4 to 9 pairs. For the teats, they also have 4 to 9 pairs. Per teat can have 2 strict canals, and the positions is abdominal. So this is the mare strict canal, so that's the reason why. So that's 1 teat with 2 strict canals. So it's a complex. Morphology. When you say morphology, physical appearance. So the teat has supporting tissues like the skin, the lateral suspensory ligament. We also have the median suspensory ligament and the lamellae. So the lateral suspensory ligament gives major support to the mammary glands, and it's non-elastic, while the median one is elastic and forms longitudinally between the 2 halves of the udder and is fused on the abdomen, while the lamellae is continuous with the interstitial framework of the udder, adding support. So this is how it looks like. So that's the skin. And we have the median suspensory ligament here. So when you're going to cut this or dissect this, you can see the suspensory ligaments. And also you have the lateral suspensory ligaments here, and we have the lamellae. If you're going to open the skin, you can see the ligaments. We also have the synthesis and transport of milk. So like the lungs, the ones that produce the milk are the alveoli, the alveolus. And each alveolus is being put into lobules, and these lobules are also being placed into different lobes. So this is the morphology, what is inside the mammary glands. So by the way, we go back to the morphology. So the epithelium, we have the myoepithelial cells here. These are the basic milk secreting units. And over half of the milk stored in the mammary glands will be stored in the lumen of the alveoli. That's from Bearden. Okay. For blood supply, you have the arteries that supplies blood to the teats or mammary glands, while the veins are the ones that remove the carbon dioxide and waste products. So when you say external pudic artery, this is the main blood supply for mammary glands for those species that have inguinal mammary glands. For external thoracic, you can have this in your sows. Also the external pudic, because there are some sows do have still has teats in their inguinal area, but primarily it's abdominal. For veins, so external pudic veins and subcutaneous abdominal veins are those with the ones that are found in those with species that have inguinal mammary glands, while the external thoracic one are for those veins that are also for your sows. Musculature of the teats, myoepithelial cells. So these are functions like smooth muscles, but are of ectodermal in origin. So it's myoderm. Myo meaning it's muscle. Later on, we'll find out the smooth muscle later on in your anatomy. And these are contractile tissues which play a major role of milk ejection or milk letdown. Hormonal regulation. There are two hormones that regulate milk. First is the prolactin, which is the one that initiates lactation. And this one is being released by the anterior pituitary glands. The stimuli or the stimulus for prolactin is the sucking motion. So the moment the preemie or the first animal or first fetus, especially for polytocous animals like the sows, polytocous meaning it produces more than one offspring, they will once the first one will suckle it, it stimulates prolactin. And that is an example of a positive feedback mechanism. Prolactin also interact in synergy with the following hormones like cortisol, insulin, growth hormone, which is also known as somatotropin, and thyroid hormone. In your anatomy, I developed one chapter for hormones, just in case, just to remind you. But oxytocin is the primary hormone for milk ejection or milk letdown, the release of milk. Oxytocin is also being governed by the positive feedback mechanism, same mechanism that produces prolactin. So for example, if the animal, again, is sucking, it can also it stimulates the posterior pituitary glands, because this one is being released by the posterior pituitary glands to produce this one. Also, oxytocin is used to stimulate the contractions of the uterus. Yes, this hormone is widely available. It's readily available actually in agri-vet supply stores. And most of the breeders, even for dogs, has this on hand, because once the bitch starts to have uterine contractions, they will inject this and it hastens this one. You don't need actually oxytocin, injectable oxytocin, if you have a polytocous animal, because again, once the first batches of fetuses that were born are able to suckle, this will increase and stimulate the production of oxytocin. So this is what you call the feedback mechanism. So this one, I'll explain this one, this draw wave. So when the newborn or neonate will start to suckle here, it will send signals, because these are nerve endings that are found in the mammary glands. It will send signals via these nerves and going to the femoral nerve, going to the lumbar or lower back, to the spinal cord, and goes to the brain. For the prolactin, it has to have a stimuli coming from the hypothalamus, if you can remember, before the anterior pituitary glands will produce the prolactin. But for oxytocin, it will go the stimuli will go directly into the posterior pituitary glands, and the posterior pituitary glands will release oxytocin into the bloodstream and going towards the different arteries, extrapubic artery, so that there's the letdown or ejection of milk. I hope you understand that. As I mentioned from the previous video, there's colostrum. So milk produced 12 to 24 hours after parturition, and this is a higher protein content than normal milk. It also has immunoglobulin G, or IgG, which is an antibody that protects offsprings from certain diseases. So, for example, the dams have been vaccinated against certain diseases. The antibodies coming, they already have antibodies against certain diseases that can protect the animal or the neonates. Colostrum also has a higher vitamin A, which is deficient in newborns, and colostrum has higher mineral content. By the way, you might be asking, Doc, are there deficiencies regarding, is milk really full? Yes, it's a complete food. However, for our beloved sows or pigs, their milk is deficient in iron. So it's a common practice, especially on the day after they're born, the piglets, they have iron dextran injections, which is given intradermally to them because their sows have deficient iron in their milk. Now, mastitis. So mastitis comes from the word mast, which is mammary, masti, which is mammary glands. Itis is inflammation. So it's literally an inflammation of the mammary glands. It can either be caused by bacteria or fungi. Common causative agents would include your Mycoplasma, Staphylococcus aureus, Streptococcus agalactiae, and Corynebacterium bovis for your cattle. All are spread through direct contact like milker's hand or liners of the milking unit. That's for commercial milk farms. And Mycoplasma is a bacteria that causes mastitis that can be transmitted through aerosol transmission. So that ends our chapter 10, or the second to the last topic. If you do have questions, please do ask. And I really appreciate it. And I will see you guys with our last topic. So take care and goodbye.